is absolutely convergent, conditionally convergent, or divergent. So first, let's identify b sub n. B sub n is going to be 1 over square root of n. So b sub n is going to be greater than 0 for n greater or equal to 1. We can see that the sequence is decreasing for n greater or equal to 1. Let's take the limit. So when you take the limit as n approaches to infinity, b sub n, you're going to get 0. Therefore, we know the series. This series converges by the alternating series test. Now, we need to see whether the series is conditionally or absolutely convergent. So to determine absolute convergence, we go back and take a look at this series from 1 to infinity, 1 over to the square root of n. This series turned out to be divergent because it's the p series. And this p series, p is 1/2, and 1/2 is less than 1. Therefore, it's divergent. So the original series, which is the alternating series, this series is conditionally convergent. For this series, I'm gonna determine whether the series is convergent or divergent by using the ratio test. So for the ratio test, first I want to identify what is a sub n. A sub n in this case is gonna be -3 to the n power over n squared. So we're gonna take the limit, the absolute values of a sub n plus 1 over a sub n. So what we have is the limit as n approaches to infinity, -3 n plus 1. This is a sub n plus 1 over n plus 1 squared. And I'm going to multiply by the reciprocal, so n squared over -3 to the n power. You can see that I can simplify this one with this one. I can also take the 3 out. So I ended up with the limit as n goes to infinity, 1 over 1 plus 1 over n squared. By the way, since I'm working with the limit, I just divide everything by the LCD. So you see right here on the bottom, we have 1. So the limit is going to be 3 times 1 equals to 3, which is greater than 1. So the series is divergent by the ratio test. For this problem, same thing. I would like to identify a sub n. So a sub n is going to be -3 to the n power over 2n plus 1 factorial. We're going to take the limit and approaches to infinity, absolute values a sub n plus 1 over a sub n. So I'm going to plug it in and approaches to infinity. It's going to be -3 n plus 1 over 2 n plus 1 plus 1 factorial. Multiply by 2 n plus 1 factorial over -3 to the n power. So when I simplify, On top, I still have a negative 3 to the first power, which is negative 3. Now, to simplify the factorial, you can see that the 2n plus 1 factorial is going to cancel out. So we ended up on the bottom with 2n plus 3 and 2n plus 2. Because you can see right here, if you simplify this one right here, you're going to have 2n plus 2 plus 1. So that's 2n plus 3. And don't forget, this is factorial. So we left with two terms, 2n plus 3 and 2n plus 2. Now, when you take the limit, it's going to be 0. Therefore, the limit as n goes to infinity, negative 3 times 0 is going to be 0. And 0 is less than 1. So therefore, the series is absolutely convergent by the ratio test.